Alright, for our next problem from Chapter 5, there are 150,000 people in the city when the Black Death strikes. A year later, there are only 136,000 people. Now when I see something like this, I'm going to create some data points. Namely, well, what kind of points? Well, the independent variable seems like time, or t. And the dependent variable would be p, or population. Now the 2 points that were given are that initially there are 150,000. I'm going to make that shorter and make it 150 because we're allowed to chop that off as long as we interpret our answer correctly in terms of thousands of people. And I also have the point that at 1 year there are 136,000. Now, it says in the problem, but not on the board, that we are to assume that this is an exponential decay. So that means we need PERT. Alright? P, in this case, is our initial population. That should be simple enough. It's 150. So, and I'm also going to modify this so that it's now population in terms of time is equal to 150 e to the rt. Now, r is a constant, t is a variable. We need to find r. Well, we have a data point that we haven't used. It may look like we didn't use this, but that's exactly how we found the 150. Plug in 0 to t, e to the 0 is 1, so p has to be 150. So what I'm going to do is I'm going to plug in 1 for t, essentially making this e to the r. I'm going to plug in 136 for my population at that time. So 136 is equal to 150 e to the r. Like I said, t is 1, so those multiply out to r. Solve for r. It's the only unknown in this equation. So I divide by 150, so I get 136 over 150 is equal to e to the r. And at this point, I have an unknown quantity in an exponent that I want to get down, so I need to use logarithms. Since this is base e, the natural logarithm is the natural choice. So I'm going to take ln of both sides, and this turns out to reduce to 68 over 75. And that equals r, which when you plug into your calculator is negative 0.098. Realistically, that means that they're losing about 10% of the population every year. And if you look at it, that seems to make a little bit of sense. 10% of the population would be 15,000. So if I lose 15,000 in 1 year, I would be at 135,000, which is close enough. It balances out with the numbers that we're looking at. So I'm going to take this number, this rate, and then use it in my P of t equation. My P of t equation is now going to be 150 e to the negative 0.098 t. And with this, I can either solve for time, like when will there be a certain population, or I can do what is requested in the problem, find out a population at a given time. So they want to know what the population is in 5 years. Function notation, that would be p of 5. Set t equal to 5. This is equal to 150 e to the negative 0.098 times 5. We plug that into our calculator, and we should get 91.903, properly rounded. Now remember, when we made our points, we said that our populations would be in thousands of people. So the population is actually 91,903 people, which is a fairly significant decay from the 150,000 that we started with.